These are the answers to worksheet, review worksheet 2K. All the problems up to 24. I excluded 25. This is a system of the equations that they want us to graph. I'm going to do this first one in red. They are both already in slope-intercept form, which is what we need to graph. So I'm going to have my m be 1 over 1. That's the number that's in front of x. I can always stick a 1 there if I need to. My beginning is going to be a 1. So I start at 1 and I move up 1 and over 1 to the right 1, I should say, all the way through the graph. These lines need to be straight, so please make sure you're using your straight edge. I have the benefit of technology here. And I'm going to make this one red. Arrowheads. And we must have a label. So y equals x plus 1. Second one, again, already in slope-intercept form. My m is equal to negative 1 over 1 this time. My beginning being at 3. Start at 3, go down 1 and over 1 all the way through. You can see already where the point of intersection is, which is great. Again, for all of your lines, regardless of that, the fact that you can see them, still should be edge to edge, because you never know where it's going to end up. Arrowheads on the ends, label, and then we should be circling the point of intersection and labeling the point of intersection with its coordinates. That particular point of intersection is 1, 2. Number 2 is a set of inequalities. They are both also in slope-intercept form. I'll do the first one here in black. My slope is 2 over 1. My beginning, my y-intercept is negative 1. So we start at negative 1, and we move up 2 and over 1 all the way through the graph. Now this sign right here does not have a bar underneath it. That means we have to have a dashed or broken line. I'm going to create my broken line here. I am going to label. And with all inequalities, we need to shade. Now, I like to use my highlighters for shading here. And I'll show you why momentarily, but I will color in the entire area of what needs to be shaded with a highlighter. And you'll see momentarily why. And I actually use these colors of yellow and blue. And I will show you momentarily why I do that after I do the second one. Second one I'll have in red here. Again, slope is negative 1 over 1. My beginning is 2. So I'll start at 2 on the y-axis, and we're going down 1 and over 1 all the way through. This, because of this sign right here, the bar underneath it, it's going to be a solid line. So I'm going to pick the solid line this time and go up all the way through. Arrowheads. I'm actually going to change that line, make it look red. And now we need to shade. This is greater than or equal to. So I need to go above the line and include, I want to include the up arrow on the y-axis. So I go to my other highlighter, which is blue. And you're going to start to see exactly why I do this. You can see that the portion where the solution sets intersect has now turned green. And again, nobody will ever prevent you from using highlighters on the regions. We should be labeling this with an S. Number 3 says to solve the system by elimination. Elimination means we want to eliminate one of the variables. The easiest way to do that is to multiply. I'm going to eliminate x. I chose to eliminate x. And when I want to eliminate x, this 3 right here is what I want to multiply the whole top equation by. That 1 that's in front of that one is what I want to multiply this whole bottom equation by. Watch what happens when I do that. I end up with 3x plus 9y equals 39. And then the other one just stays the same. But what I've done here is I've made both x's exactly the same. And that's what I want to do for elimination purposes. To eliminate, I'm going to subtract. So 3x minus 3x is 0x. Those go away. Now you have to be careful. That's a negative 1 in front of that. 9 minus negative 1 gives me a positive 10y. And we're not to touch the variables when you're adding and subtracting. 39 minus a negative 11 gives me a positive 50. Then I'm going to divide by 10 to solve for y, and y equals 5. Now, from there, I want to find my x. You're going to plug the 5 in for y in either one of the equations. It doesn't matter. Take the top one. X plus 3 times 5 equals 13. 3 times 5 is 15. So x plus 15 equals 13. We subtract 15 from both sides and get x equal to negative 2. I need to be able to write this in coordinate form now. So my final answer is negative 2, positive 5. Number 4, write a system of equations to model the situation solved by any method. You and some friends buy hamburgers. A hamburger costs $1.50 and a milkshake costs $2. The total bill for 12 items is $21.50. So the first thing I'm going to do is let x be the burgers. And again, the reason I use x and y is because it's what I grew up with. No one is holding you to using x and y every time unless the problem specifically tells you what variables to use. I'm going to let y be the milkshakes. So I know they bought 12 items. That means the burgers plus the milkshakes is equal to 12. I know it cost them a total of $21.50. Which means then what I can do is I have $1.50 per burger and $2 per milkshake. I'm going to choose to do this by a substitution. So what I'm going to do here, I'm going to decide I'm going to substitute for x. So x plus y equals 12. I'm going to solve for x by subtracting y from both sides. And now x is equal to 12 minus y. I'm going to take that expression right here, and I'm going to put it back in for that x right there. So 1.50 times the quantity, 12 minus y, plus the original 2y equals 21.50. Then sit there and do your math. So 12 times the 1.5 is 18, minus 1.50y plus 2y equals 21.50. Combine the like terms. This gives me 18 plus 0.5y equal to 21.50. From here, I want to subtract 18. Sorry, I'm running out of room here. Move down just a little bit. So now 0.5y equals $3.50. Divide by 0.5 on both sides, and y equals 7. Go back in either one of our equations. So x plus 7 for y that I just got is equal to 12. Subtract 7, x equals 5. Need a conclusion statement because it is a word problem. Therefore, they bought 5 burgers and 7 milkshakes. Sounds like a rockin' good time. Next, 5 is also a system of equations word problem. Collection of dimes and nickels is worth 55 cents. 7 coins in all. How many dimes and how many nickels? Let n be nickels. Again, use any variables you want. I'm showing you that you can change it up. Let d be dimes. There are 7 coins in all, so n plus d equals 7. It is worth 55 cents. Nickels are worth 5 cents, 0.05, plus dimes being worth 10 cents. Again, I'm going to solve this by substitution. I'm going to do n. So n is going to be equal to 7 minus d. So 0.05, substitute what you have in for n, which is 7 minus d, plus 0.10d equals 0.55. Do the distribution here. We have 0.35 minus 0.05d plus 0.10d equals 0.55. Combine like terms, 0.35 plus 0.05d equals 0.55. Subtract 0.35 from both sides. We have 0.05d equals 0.20. Move down a touch here. Divide by 0.05. D equals 4. Plug it back in. So n plus 4 equals 7. Subtract 4. N equals 3. Now at this point, I can check my work quickly to see if that works. And 4 dimes and 3 nickels does equal 55 cents. So it is a good combination. Now that is not a guarantee that I picked the correct answers, but it's definitely a quick check. The guarantee would be is if I went back in and I plugged everything in to make sure it worked in all the equations. Therefore, we have 4 dimes and 3 nickels. Go back over the other side with number 6. Suppose you plant a tree in fertile soil and provide the proper amount of water and fertilizer. The tree is healthy and grows steadily. Sketch a graph showing what the height of the tree might look like over time. So we have time and height. Now usually trees are somewhat have a little bit of height, so I may want to not necessarily start at 0, but if it's growing steadily, that's probably what my graph looks like, and it'll just continue to grow, of course, until it dies. 7, model the rule f of x equals negative 2x plus 1 with a table and a graph. So the table, x and f of x, use any values you want. So here's 0, 1, and 2. When you plug in 0, you get 1. When you plug in 1, you get negative 1. When you plug in 2, you get negative 3. Sketch of the graph. We have the x and f of x axes. You should be doing this on graph paper. I'm just going to do a quick mini demonstration here. So 0, 1 would end up here. 1, negative 1 would end up here. 2, negative 3 would end up here. And arrowheads along with the original function. Number 8, we want to plug in the values in L1 and L2 for our equation. So we put 1 and 2 in L1, and we put 295 and 272 in L2, and we run our linear regression. And we come up with y equals negative 23x plus 318. Write an equation for point slope form for number 9. Point slope form is y minus y1 equals m times the quantity x minus x1. So we have y minus a negative 4 equals negative 3 times the quantity x minus 1. Do not leave it with a double negative, so we have to have y plus 4 equals negative 3x, negative 3 times the quantity x minus 1. And that is your final answer because they want it in point slope form. Number 10, we want to know the range. So plugging all of these domain values in, f of negative 6 would be equal to negative 23. F of 4 would be equal to 7. And f of 8 would be equal to 19. Function rules for 11 and 12. The amount of medicine is mx equal to left an 8-ounce bottle after x doses of 0.25 ounces. We start out with 8 ounces. We're taking away 0.25 times the number of doses, which is x. And finally, for 12, write an equation for direct variation that includes the point 4, negative 8. We always start off with y equals. And to get to negative 8 from 4, we multiply it by negative 2. So y equals negative 2x. For questions 13 and 14, we wanted to find the common difference in the arithmetic sequence. And what we're looking at here is the fact that 3 is being added each time to get to the next number. So the difference here, difference here is equal to 3. Here we're adding 12 each time to get to your next term, so your common difference is equal to 12. Number 15, they wanted the equation in slope-intercept form. Again, a reminder to you that is y equals mx plus b. And to get there, we need to divide everything by 2 all the way through. And that gives me y equals 2x plus 3. Number 16, if the balance in a checking account B is modeled by the function b of x equals negative x plus 1500, what is the change in b per unit of time? The rate of change, will be whatever's in front of the x. So the change in this case is going to be negative 1. For 17, we want to find the x and y intercepts of the line. To find the x-intercept, we plug in 0 for y and solve for x. So x plus 0 equals 3, making x equal to 3. And so my x-intercept is 3, 0. For the y-intercept, we want to plug in 0 for x and solve for y. And that also gives me y equals 3. That is a coincidence that would happen. And so my y-intercept is 0.3. Cost of hiring movers is 200 plus 50 each hour they work. If the cost were modeled by a linear equation, what would be the slope? The slope would be here, 50 each for each hour. That is the rate of change. So your slope would be 50. I want to make a scatter plot and describe the correlation for number 19. So we'll make the scatter plot first, 2, 7, and 6, 4, and 5, 4, 4, 3, 3, 5, and 5, 5. And if I'm taking a look at this, while one might generate that we have negative correlation, I would disagree with that statement due to the fact that we are going negative from 2 to 3 to 4, but then we go back up for 5 and 6. In my opinion, this would be no correlation because of the scatteredness of these dots. We want to graph in number 20, y equals the quantity x plus 2, the absolute value of that, by translating y equals x, y equals the absolute value of x. Again, y equals the absolute value of x looks like this. Remember, all absolute value graphs look like a V. And plus 2, this is where things get weird when it's on the inside. Plus 2 is actually telling you to move to the left 2 units. So let me change colors here. Y equals the absolute value of x plus 2 would actually be going right here. You're just moving that entire graph 2 units to the left. And we do want to label this as such. Remember, all graphs, especially when you have 2 of them on there, need to be labeled. 21, use the graph to find the slope and write the equation of the line. So a point is right there. That point is 0, -1. And I have another point right here, which would be 1, 1. If I look at my slope, I've gone up 1, up 2, and to the right 1. So my slope, so I'm going to write this equation line. So y equals, I'm going to put it in y equals mx plus b form, slope-intercept form. I need my m and b. My slope in this case, I'm going up 2 and to the right 1. That is a slope of 2. Leave the x alone. My y-intercept here is -1 because that's where it crosses the y-axis. So I put -1, and I have my equation of y equals 2x minus 1. And next, we want to know, are the lines parallel, perpendicular, or neither? If I test these slopes, if I do -1/2 times 2, that gets me to -1. That is the perpendicular test that we've talked about in review. These lines are perpendicular. For 23, determine whether 2, 8 is a solution of this particular inequality. Explain why or why not. We'll plug the points in. So 8 is greater than or equal to 2 times 2 plus 3. So 2 times 2 is 4 plus 3. So 8 is greater than or equal to 4 plus 3. 8 greater than or equal to 7. That is a true statement. And so it is a solution. And my explanation is my work, so I don't have to actually use words if I don't want to. And finally, for 24, compare the slope of the function f of x equals 2x plus 1 to the slope shown by the table. So the slope here for f of x is 2. So let's see what the slope is for this. I want the change in y over the change in x. So this can be P1. This can be P2. Remember what my slope formula is. M is equal to y1 minus y2 over x1 minus x2. Those are not exponents. They are subscripts, just names. x1 and y1 come from P1, which is 0 and 0. And x2 and y2 come from point 2. What we have here is negative 2 over negative 1, which is equal to positive 2. So the slopes are equal. If you had any issues with any of the questions on this particular worksheet, please make sure you are emailing me or consulting me in class.